Let's assume that we have the following mapping. So f is going from r square onto r square, such that for every xy we have y x minus y. So we want to show that this mapping is linear. So that's our aim. Show that f is a linear mapping. Okay. So to do that, we want to take any combination of two vectors in R squared and show that their image under f is a linear combination of these two vectors. Okay, so we take, let alpha beta in R, also let x1 be x1 y1 and x2 be x2 y2, two vectors in R square. Okay, two vectors in R square. We want to combine these two, so with alpha and beta. So we will have alpha x1 plus beta x2. Okay, so note that alpha x1 is just alpha x1 alpha y1. Beta x2 is alpha x2 beta y2. Okay, so here we have alpha x1 plus beta x2 is gonna be alpha x1 plus beta x2 alpha y1 plus beta y2. So now we're gonna see their image. Think of this as the first component of this vector, this one as the second component of this vector. So the image is gonna be what under R square? It's gonna be the second component first, and after that the first component, the x component, minus the one component, this one minus this one. Let's see. We have f of alpha x1 plus beta x2. Okay, so let's write it in this form. This is f of xy. Okay, so this is f of xy, this one here. So this is sorry, let me write it here. F of xy is given by y x minus y. Sorry, this is the wrong one. Okay, so here we have f alpha x1 plus beta x2 alpha y1 plus beta y2. Okay, so here the first component here in the image is what? Y. So y is this one. So it's going to be alpha y1 plus beta y2. The second one is going to be x minus y. X is this one, the x component. Alpha x1 plus beta x2 minus y. It's this one here. Alpha y1 minus beta y2. Okay. Now we try to combine the alphas with the alphas and the betas with the betas. This would help us a lot. So we have alpha y1 plus beta y2, and here we have alpha x1 minus alpha y1 plus beta x2 minus beta y2. Okay, now we can write it in this manner. Alpha y1 alpha x1 minus alpha y1 plus beta y2 beta x2 minus beta y2. Okay, try to write to make it simple. Try to get the component that they have the alpha together, the component that they have beta together. This would make it easier for you if you have like x, y, z, or maybe four coordinates. Okay, it's gonna be, this is the quickest way to get the result. So here we can write this one as alpha y1, and we can factor here by alpha. We get alpha x1 minus y1 plus beta y2, and we factor here by beta x2 minus y2. Okay, so now let's take the alpha outside. We get alpha y1 x1 minus y1. The same thing here, we'll take it outside. Beta y2 x2 minus y2. Okay, so now think of this map. So for xy, the first component for the image is y, and the second component is x minus y. So here, so for x1, the first component, okay, remember our f of xy is y x minus y. So for x1, which has component x1, y1, so it has, the first component is gonna be y1. The second component is x1 minus y1. It's x minus y. So we have alpha f of x1. The same thing for beta, for y2, for x2. I called it x2, yes, I did. I called it x. Beta f of x2. Okay, this proves that what? That f of alpha x1 plus beta x2 is alpha f of x1 plus beta f of x2. For any alpha beta in R and any x1 x2 in R squared. This means that this proves that f is linear. Okay, that's what we need, that f is linear. Okay, there are other ways, but this is the general way. Do it for any two vectors. Combine and do any linear combination and show it like this one. Okay, if you have more than two coordinates, like 3 or 4 or 5, do it this way, and it will help you a lot. So if we will add one more when we do with R3 or R4, and we're gonna see that we have to pay attention to the order and to get the result. One more thing to do is that here, given our first vector x1 and our second vector x2, so the sum here is x1 x2, but when I do alpha x1 plus beta x2, let's assume that alpha and beta are bigger than 1. So this is alpha x1. This is beta x2. So this is a stretching that I get. Okay. So when I do the image of this one, and I see that I still have the same stretching. Okay. That means that the image, if I stretch the vector by alpha, the image is going to be stretched by some alpha. Okay, that's what it means. The sum is going to be stretched by this one, the first component by alpha, the second one by beta, so the image is going to do the same. I will do one example or two with the ruler, okay, where we count and compute the exact vectors. Like we do it exactly on one, like x1, we're going to do it in x1, 1, 2, and x2 is, let's say 0, 3. Okay, and we multiply this one by 2 and this one by 3 and see under the map what happens. This will help us. But anyways, we have shown this one, and that's what it means. Like the linear combination of the some vectors is going to be a linear combination of the image. Okay, thank you.